Hello everyone, in this video I'm going to present solutions to 10 problems levels 1 to 10 on resultant of the general 3D4 system, and this is part 1. So I plan to present 15 problems here. So this is the first part. Although there are uh, previous videos that I uploaded on finding the resultant of the general 3D4 systems. So these 11 problems, levels 1 to 10, are just additional problems. A 46-pound force F and a 2,120-pound hinge couple M are applied to corner A of the block shown. Replace the given force couple system with an equivalent force couple system at corner H. So this is corner H, then we have a given moment and we have a force. So we have to resolve this force into its components, transfer it at H. Take note that M is a couple is a free vector. You can transfer it anywhere on anywhere. So, but F here is a fixed vector. It produces moment at H. So we have to obtain the moment of F about H, and that is by crossing the position vector HA with F. Then the result combined with the moment. And this moment here, the given couple, we will resolve it into its components also. So for the solution, F is 46. Quantity, it is directed forward 18I, along Y downward negative 14J, then along Z to the negative direction 3K over square root of 18 square plus 14 square plus 3 square. Simplifying, F is 36I minus 28J minus 6K. So that's the force. Then moment is, it is directed in that direction. This will be your four fingers in this direction. You will notice that your right thumb will point from A to C. Your right thumb is pointing C. So therefore, moment in transforming moment into its components, it is magnitude times, it is directed to the negative x direction, negative 45I, and along y 0, along z, it's 28. From A to B, that's negative 28. So over square root of 45 square plus 28 square. So M is negative 1,800 I minus 1,120 K pound inch. So let us evaluate. So the resultant couple is RHA cross F plus M. So this is the resultant couple at H, RHA cross F plus M. You may call this C sub R if you want. So RHA, H to A, that's 45I plus 14J. So RHA cross F is 45, 14, 0. Components of force 36, negative 28, negative 6. Then unit vectors, copy the elements of the first two columns. 45, 36I, 14, negative 28J. So evaluate the determinant, just like evaluating determinant. 14 times negative 6I minus 0. So RHA cross F is equal to negative 84I. For J, 0 times 36, 0. Then minus negative 6 times 45. So that is positive 6 times 45. So 270J. For K, 45 times negative 28. That's negative minus 36 times 14. Another negative. So negative 1764 K pound inch. So finally, the resultant couple at H is negative 84, then negative 1,800 I, 270 only, then negative 1764 and negative 1120 K. Combining, so this is the force, 36I minus 28J minus 6K, and the couple at H is negative 1884I plus 270J minus 2884K pound inch. So these are the force and couple system at H. The shafts of an angle drive are acted upon by two couples shown. Replace the two couples with a single equivalent couple specifying its magnitude and the direction of its axis. So that you won't be confused, if you curl your four fingers in this sense along Y, so this is equivalent to a couple that is pointing downward. Your right thumb will be pointing downward like that. Therefore, this is in vector form negative 8J pound inch. So likewise, if you curl your four fingers, right hand four fingers, your right thumb will be pointing in that direction. So this couple is negative 8J, this couple is negative 6K. So C sub R is negative 8J minus 6K pound foot. Then in the components, C sub R equals square root of 8, the magnitude 8 square plus 6 square, so 10 pound foot. Then cosine of theta x is equal to 0. There's no x component over magnitude 10. Theta x is 90 degrees. That's the direction. Cosine theta y is equal to negative 8 over 10. So theta y is more than 90 degrees. That's 143.1 degrees. Then cosine theta z is negative 6 over 10, or CRZ over magnitude. So theta z is also more than 90 degrees, 126.9 degrees. So the answer, the magnitude is 10 pound foot couple. Then theta x 90 degrees, theta y 143.1 degrees, theta z 126.9 degrees. Determine the resultant of the three cable tensions that act on the horizontal boom if T sub 1 is 900 pounds, T sub 2 500 pounds, and T sub 3 300 pounds. So let's resolve each tension into components in vector form. So T sub 1 is magnitude 900, then it is directed to the right 3 feet, along X, along Y negative 8 backward, along Z upward 4. So T sub 1 in vector form is 900 times 3i minus 8j plus 4k over square root of 3 square plus 8 square plus 4 square. So the components of T1 are 286.2, negative 763.2j plus 381.6k pounds. T sub 2. T sub 2 in vector form is 500, then negative 4i, negative 8j, positive 4k. So T sub 2 is 500 times negative 4i minus 8j plus 4k square root of 4 square plus 8 square plus 4 square. So T sub 2 is negative 204.1i minus 408.2j plus 204.1k pounds. Finally, T3 is 300. It is directed backward negative 8, then downward 6. So it is T3 in vector form 300 times quantity negative 8j negative 6k, square root of 8 square plus 6 square. So it is equal to negative 240j minus 180k pounds. So the resultant is simply the sum of these x components, y components, and z components. So R is 286.2 minus 204.1 minus 240. Minus 204.1, sorry, this is J. Then negative 760.2, negative 408.2, negative 240 for J. Then 4K 381.6 plus 204.1 minus 180. So combining R is 82.1I minus 1411J plus 405.7 K pounds. So that's the resultant in vector form. So this is the X component of resultant, Y component of the resultant, then Z component of the resultant force. Level 4. The trapdoor is held in the position shown by two cables. The tensions in the cables are T sub 1 30 pounds and T sub 2 90 pounds. Determine the magnitude of the single force that would have the same effect on the door as the cable tension. So that single force is the resultant because the two tensions are concurrent about A. The resultant will be a force through A also. So by the way, this is the horizontal position, this is the lifted position. So therefore this distance is 3 feet sine of 20, this one. So we will transform the tensions into their vector form so that we can easily see the X, Y, and Z components. So T1 is 30, then because this is 5 feet, that's 2 feet, so it is directed backward along X, so negative 3I. 5 minus 2 is 3, but in that direction, so negative 3I. Along Y is, this is 3 cosine 20, so negative 3 cosine 20J. Then along Z, 4 feet minus quantity 3 sine 20K. So 30 times negative 3I minus 3 cosine of 20 degrees, then plus 4 minus 3 sine 20. The net vertical movement along Z is 4 feet minus, because this is lifted by 3 sine 20, so minus 3 sine 20 degrees K. So 3 divided by square root of 3 square, 3 cosine 20 is 2.819 quantity square, then 4 minus 3 sine 20 is 2.974. So simplifying further, so 30 times negative 3I plus 2.819J minus 2.819J, then plus 2.974K divided by square root of 3 square plus 2.819 square plus 2.974 square. So simplifying, so these are the components of T1, negative 17.72I minus 16.65J plus 17.57K. Then T sub 2 is magnitude 90 times 2I, then plus minus 3 cosine of 20 again J, then plus quantity 4 minus 3 sine 20 degrees K. So divided by square root of 2 square plus 2.819 square plus 2.974 square. Simplifying, then we have so we have 39.48I minus 55.64J plus 58.7K. So therefore, the resultant is quantity negative 17.72 plus 39.48I, negative 16.65, negative 55.64J, then 17.57 plus 58.7K. So combining R is 21.76I minus 72.29J plus 76.27K. So we are just asked for the magnitude. So the magnitude is square root of 21.76 square plus 72.29 square plus 76.27 square. And the magnitude is equal to 107.3 pounds. Level 5, the force system shown can be replaced with a single equivalent coupled C sub r. Determine C sub r. So let's check. Along x, 400 minus 400, so 0. Along z, 300 plus 500 minus 500 is 0. So there's no resultant force, just a couple. So let's evaluate C sub Rx along x. 200, so positive sense is in that sense. So these two parallel, so no moment. This passes through, no moment. So only 200 and 500 will have moment about x. And the positive is 200 times 0.4 meter and minus 500 times 0.4. So moment OX equals 200 times 0.4 minus 500 times 0.4. The positive sense is in this direction. If your right thumb is here, your forefingers will curl in that sense. So same as 200, opposite to 500. So MOX is equal to negative 120 Newton meter. MOY here, so positive sense, if this is your right thumb, would be in this direction. So excluding these two forces because they act on the y-axis. So this 400 here is positive, but there is a couple, another force 400 same distance, so 0. So the net force would be, the net moment about y-axis is due to this 200 here. This is the positive sense, it is opposite, so it is negative 200 times 0.4. MOY is negative 200 times 0.4, so it is negative 80 Newton meter. Finally, moment about the z-axis. So all these three are parallel to the z-axis, so no moment except these two. And this one acts on the z-axis. So positive sense, if this is your right thumb, this is the curling of your forefingers. That's the curling of your forefingers. That's a positive sense. So this 400 here is opposite. So the moment OZ is negative 400 times 0.2. MOZ is negative 400 times 0.2. So it is also negative 80 Newton meter. So I just apply right thumb rule, scalar approach. These are the components of the resultant couple. Therefore, the resultant couple is negative quantity negative 120I, negative 80J, negative 80K Newton meter. And that's the answer. Replace the force couple system acting on the pipe with an equivalent force couple system with a force acting at point O. So this couple should be resolved into its components because we can move it freely to O. But this force should be resolved into components because it will have moment about O. So to solve for its moments, you can use scalar approach, but I will use vector approach here. So it is ROA cross the force plus this couple here when transformed into its components. So F is 40 negative 3I negative 2K over square root of 3 square plus 2 square. So 40 is directed right backward along x, so it's negative 3I, then downward along z, negative 2k over square root of 3 square plus 2 square. So F is negative 33.28I minus 22.19k pounds. So that's the force at O. Then 90, if you have your right thumb, this will be your forefingers curling in that direction. Your right thumb is pointing towards O. So the couple is in that direction. So this couple, if I call that C sub, so this is the resultant couple, ROA cross F plus C sub 1. Then C sub 1 transformed into its components is 90 times along X negative 3I, along Y negative 5J. So it is to the backward along x, so negative 3i, opposite to y, negative 5j, over square root of 3 square plus 5 square. So C sub 1 in component form, negative 46.3i minus 77.17j pound-foot. So let's evaluate ROA cross F, where OA, position vector OA is positive 3i, positive 5j. So it is 90 times, sorry, ROA cross F is 350. There's no Z movement for OA. Then components of force, negative 33.28, 0, negative 22.19. Then unit vectors IJK. Then copy the elements of the first two columns. So for I, 5 times negative 22.19 minus 0. For J, 0 times negative 33.28 minus negative 22.19 times 3, so that's positive 66.57J. Then for K, 3 times 0, 0. Then minus negative 33.28 times 5, that's positive because minus negative 33.28 times 5, 166.4. So therefore, C sub R is negative 111, then negative 46.3i, 66.57 minus 77.17j, then plus 166.4. So simplifying, this is the force at O, negative 33.28i minus 22.19k, and this is the couple, negative 157.3i minus 10.6j plus 166.4k pound-foot. Determine the force couple system with the force acting at point O that is equivalent to the force and couple acting on the arm CD of the industrial robot. Note that the arm ABCD lies in a vertical plane that is inclined at 40 degrees to the YZ plane. The arm CD makes an angle of 30 degrees with the vertical. So this is a wrench actually. So we resolve the force into its components XYZ as well as this 52 pound-foot couple because we can freely move it at O. So for the force, let's compute its XY component first, which is directed along this axis here before we resolve it into X, Y. So Fxy, this value here is negative 9.8 sine of 30 opposite. Then Fx, because it is pointing in that direction, Fxy is in that direction. So it is towards the positive x-axis, opposite to 40. So therefore Fx is 9.8 sine 30. This is 1. And this is the Fx component. So 9.8 sine 30, this value here, then this value is Fx times sine of 40. So Fx is 9.8 sine 30, then sine 40, this one, parallel to x, towards the positive x direction. So that would be 3.150 pounds. Fy, so it is Fxy, 9.8 sine 30, but because it is directed in that direction, adjacent to 40, but in that direction, because this is Fxy, 9.8 sine 30, then this is the component along y. The arrow is in that direction because this force is up to the left and forward along x. So it is negative 9.8 sine 30 cosine of 40. So Fy is negative 3.754 pounds. While Fz, this is upward, this is the component of 9.8 pounds. Simply 9.8 cosine adjacent to 30, cosine of 30. That's FC, 9.8 cosine of 30. So it is equal to 8.487 pounds. So in vector form, we now have the equivalent force at O, 3.15I minus 3.754J plus 8.487 K pounds. Then for the couple, so position your right thumb. This will be your four fingers. Then the couple is your right thumb is pointing in that direction. Therefore, this is C sub 1x is again 52 times sine of 30 times sine of 40. Because this is the direction of the x component of the couple, same as the force. So 52 sine 30 sine of 40, 16.71 pound-foot. C sub y is negative 52 sine of 30, then cosine of 40 in that direction. So C sub 1y is negative 52 sine of 30, then cosine of 40. Just like the force, because they are directed in the same manner. So negative 19.92 pound-foot. Then C sub z is just this component, 52 times cosine of 30. Positive 52 times cosine of 30. So 45.03 pound-foot. So therefore, the couple at O is ROD cross the force, because this force will have moment at O, then plus C sub 1. So C sub 1 is 16.71I minus 19.92J plus 45.03 pound-foot. So the resultant couple is ROD cross F plus C sub 1. So ROD from O to D. So this distance is 4.2 sine 40. This one. This distance is 4.2 cosine of 40. Imagine a right triangle here. So from O, we go backward 4.2 sine 40. RODX negative because it's backward. Along Y, it's positive 4.2 cosine 40. Then along Z, upward 2.8. It's given here. So RODX is negative 4.2 sine of 40, negative 2.700 feet. While RODY, which is the adjacent side of this imaginary right triangle with hypotenuse 4.2, is 4.2 cosine 40. Then, so 3.217 feet. Along Z, it's same plane as this, XY plane, so you just move 2.8. So there's no need to say RODZ is 2.8. It's obvious in the figure. So let's evaluate ROD cross F. It is equal to negative 2.7, 3.217, then 2.8. Components of force, 3.50, negative 3.754, 8.487, then unit vectors IJK. Copy the first two column elements, then evaluate the determinant. For I, 3.217 times 8.487, then minus negative, so this is plus 3.754 times 2.8. So that would be 37.81I. Then for J, 2.8 times 3.15 minus this product, but this is negative, so plus 2.8 times 3.15 plus 8.487 times 2.7. So that's why we have 31.73J. For K, negative 2.7 times negative 3.754, that's positive, minus 3.15 times 3.217. So the result is 0. I think there's no K here. So again, for K, 2.7 times 3.754 minus 3.15 times 3.217. that's 0. So this is ROD cross F. Therefore, C sub R is quantity 37.81 plus 16.71 I, then plus 31.73 minus 19.92 J, plus 45.03, plus 0 plus 45.03 K. Combining, so this is the force 3.15 I minus 3.754 J plus 8.487 K pounds. And the couple is the value here combined. So 54.52 I plus 11.81 J plus 45.0 K pound-foot. Level 8, the resultant of the forces P1, P2, and the couple C is the force R equals 12 pounds acting at point A. R is not shown in the figure. So determine P1, P2, and the couple, magnitude of the couple, just the magnitude. So first, we resolve this couple into its components so that it's clear. So P1 plus P2 equals 12, summation forces along Z. So P1 upward plus P2 equals resultant, which is 12K. So meaning to say RZ is 12 pounds, so equals 12. Then the couple is magnitude of the couple. It is directed along X 15I, then along Y negative 20. 15, 5 to the left, opposite to Y, so negative 20J over square root of 15 square plus 20 square. Simplifying, this is the X component of the couple, 0.6C. Then the Y component of the couple, negative 0.8C. Since the resultant is acting at point A, so this is Cx and that is Cy. So meaning to say, summation of moment about Cx is 0. Summation of moment about Ax is 0 because the resultant, the moment of the resultant at Ax is 0. The resultant is acting at A. And summation of moment about Ay is also 0 because the resultant acts at A also, Ay. So C sub Ax equals 0 and it is equal to 0.6C, the component of the couple. Then the moment of P1, because this is Ax, the positive sense of moment, this is your right thumb, so this will be your forefingers, curling of your forefingers. So the moment of P1 is negative, P1 times moment arm 20. The moment of P2 is also negative. It is opposite to this curling. So minus P2 times 15. So simplifying, 20 P1 plus 15 P2 minus 0.6 C equals 0. Call that equation 1. Then moment of the resultant about AY, this is AY axis. If this is your right thumb here, the curling of your forefingers would be in this sense. This is the same sense as the moment of P1. So P1 is positive. P2 is 0 because it is on AY axis. Then the component of the couple is negative 0.8 C along Y. So C sub AY equals 0. It is negative 0.8 C component of the couple. Then the moment of P1 is positive P1 times 15. So simplifying, 15C1 minus 0.8 C equals 0. Call that equation 3. So solving equations 1, 2, and 3 simultaneously, we can now determine P1, P2, and the couple. So P1 is 28.8 pounds, P2 negative 16.8 pounds, and the couple is 540 pound-inch. Determine the resultant of the force system acting on the semicircular plate. So this is the semicircular plate. This couple is pointing the negative y direction. So if we transform it into vector form, that's negative 500 J pound-foot. So C sub 1 is negative 500 J pound-foot. Then this distance 200 from the y-axis is 3 sine of 30, while that distance is 3 cosine of 30. So moment about resultant couple about x-axis is equal to, so this is the positive sense, so 300 times 3. Positive sense of moment about x-axis is your right thumb here, curling of your forefinger. So this is the same sense as the moment of 300. 300 times 3, radius is 3 feet. Then minus 200, then this distance is 3 cosine of 30. Right triangle. That's 3 cosine of 30. So minus 200 times 3 cosine 30. So the x component of the resultant couple is 380.4 pound-foot. Then, about y. C sub ry equals negative is, if this is your right thumb, the positive sense is in that direction. So 200 is positive, 200 times 3 sine of 30, this is the moment arm, 300 sine 30. Minus 120 times 3, 300 is not involved because it acts on the y-axis. Then minus 500, which is the original couple. So the y component of the resultant couple is negative 560 pound-foot. So the magnitude of the resultant is 120. C sub z is 0, by the way, because all these forces are parallel to the z-axis, and this is negative 500 J, no K. So C sub z resultant, the z component of the resultant couple is 0. So we imagine that the resultant R is 120 minus 300 minus 200, so it is equal to negative 380 pounds. So that's the resultant. Then because the resultant is a force, then we must specify its line of action, not the components. We must specify its line of action. So we imagine that the resultant force is here, so that xr is positive, yr is positive. You just imagine. So moment about y-axis, this is your right thumb, is positive sense is in that direction. Since r is downward, has the same moment as sense as the positive moment about the y-axis. So we equate c sub ry, which is negative 560, to the moment of the resultant, which is positive 380 times xr. So negative 560 is 380 times xr. Why 380 times xr? Because 380 is downward, and the positive sense of moment is in that direction. So we assume that xr is positive. The resultant is here. So xr is actually negative 1.474 feet. Likewise, if we sum up moment about the x-axis, this is your right thumb, the positive sense of moment is in that direction. This is the resultant, downward. Its moment about the x is in the opposite direction. Its moment is negative 380 times yr. Then we equate it to c sub x, which is 380.4. So 380.4 is negative 380 times yr. So yr is also negative 1.001 feet. Therefore, the answer is R is negative 380 pound through quantity negative 1.474, negative 1.001, comma 0 feet. That's it. The transmission tower OA is being hoisted into position by the cables AB and AC. The resultant of the cable tensions P and Q along with the 2,400 pound weight of tower is a force R acting at point O. So determine P, Q, and R. That's the figure Take note that the resultant is a force, single force R acting at point O. So if it acts at point O, meaning to say moment about X, about Y, and about Z would be 0. So for easy computation or analysis and solution, shorter solution, we resolve the forces into components, but I apply vector approach so that we can easily compute the components easily. It will fit the solution in this slide. So P is magnitude of P. It is directed along X in the negative direction, negative 28I. Then along Y, negative 40 and negative 40, so negative 80J. Then along K going down, negative 69K over square root of 28 square plus 80 square plus 69 square. So P is negative 0.2562 Pi, negative 0.732 Pj, negative 0.6313 Pk using the calculator. Q is along X 32, positive 32I forward, along Y negative 40 and negative 36, so negative 76J, along K going down negative 69K. So 32I minus 76J minus 69K square root of 32 square plus 76 square plus 69 square. So Q is 0.2976 Qi minus 0.7068 Qj minus 0.6417 Qk. So summation moment OX is 0 and positive sense of moment is in that direction. Y components of the forces P and Q is in that direction, so they are positive. And the only negative here is 200. Then negative also for the Z components of P and Q because the sense of moment is opposite. The positive sense of moment is in that sense. If this is the right term, that's positive sense. So Y components of Q are in that direction, so they are positive. So this is the Y component of P, 0.732P to the left. That's why it's negative, so it's to the left, but it is positive. 0.732P, moment arm is 69. For Q, plus 0.7068Q times 69. Then the moment of 2,400 is opposite, so minus 2,400 times 20. Then the Z component of P is going down, it is also negative. Z component of P, so minus 0.6313P times 40, moment arm. Then the Z component of Q is negative also, because the positive sense of moment is in that sense. So it is in that sense. So the Z component is 0.6417Q times moment arm is also 40. Then simplifying, combining 0.732P times 69 and negative 0.6313P times 40, that's 25.256P. 0.7068 times 69 minus 0.6417 times 40, that's 23.101Q. Then transpose 22,400 times 20 is 48,000. Call that equation 1. Summation moment about OY equals 0. So the positive sense is, if this is your right term, the positive sense is in that sense. So the Z component of P and Q pass through the y-axis, so 0. 2,400 is also 0. So we only consider X component of P and Q. For the X component of P, which is in that direction, this is the positive sense. So it is negative. Moment of X component of P is negative. Moment about the y-axis, while the X component of Q is positive, because this is the positive sense of moment. If this is your right thumb, this will be the curling of your 4 fingers. So negative 0.2562 times 69. MOY equals 0 equals negative 0.2562P times 69 plus Q, X component of Q, 0.2976Q times 69. Then no more equals 0. Cancel 69 or divide everything by 69. So negative 0.2562P plus 0.2976Q equals 0. Equation 2. Solving these two equations simultaneously, we can now compute P. 1063 pounds and Q 915.4 pounds. Therefore, Rx is negative 0.2562 of 1063 then negative 0.2562 times 1063 then plus 0.2976 of Q, which is 915.4. So Rx is 0 pounds. Ry is negative 0.732 of 1063 then negative 0.7068 times Q, which is 915.4. So Ry is negative 1425 pounds. Finally, Rz is negative 0.6313 of 1063, negative 0.6417 of 915.4, and don't forget we have weight of 2,400, so minus 2,400. So Rz is negative 3658 pounds. Therefore, in vector form, R is negative 1425J, negative 3658K pounds. So P, Q, and the resultant are in vector form. So that's it.